Ramesh, can you explain to me how the UART works? I mean, what's the basic idea of the UART?
So the UART, which stands for Universal Asynchronous Receiver Transmitter, is where two boards or two devices are talking to each other using a single wire. Right? This guy is transmitting and this guy is receiving.
Ooh, so just one wire. How does that work?
One wire.
Ooh.
So on this wire are going to go the bits that we want to transmit.
So we're going to send the bits.
Yes. So we're actually, UART uses the unit of communication for us. Unit of communication is what's called a frame, and for us a frame is 1 byte.
1 byte of data, but
1 byte of data. So that's 1 byte. Now that's what it's promising to send, but it's going to introduce within this frame, it's going to frame it. The word frame, as you know, a frame has boundaries, right? So there's a boundary. So there's a start bit and a stop bit and the 1 byte in between, right?
okay.
So you want to see how it
so
looks like on the line, right?
Yeah, let me
So
see what it looks like.
on the line, it's going to look like that. This is our time. We're just going to go as bits leave here and they enter the line. What do they look like? So at any point in time where there's no transmission, we say that the line is idle.
Okay.
For us, idle is a high. That's 0. This is 3.3 volts or whatever your high is. That's idle. The instant we want to transmit, we're going to send a start bit.
Nice.
The
Start with start. Okay, that
Yep.
sounds right.
We say the start bit, and the start bit for us is a 1 bit. It's 1 bit time, whatever this 1 bit time is, where we go from the idle to a 0. So in some sense, we say a 0 from idle is your start bit.
Is it always 0 or can it be something else?
It'll always 0
All right,
because
it's
it
always
has to be a transition, and because we're at a
Okay.
high and then we go low, that's our transmission.
Okay.
Now we're going to send our byte.
All right.
Now, how do I send my byte? Well, we're going to send our byte from the least significant bit onward. So the least significant bit first.
Okay.
So whatever your least significant bit, let's take a simple example. Let's say I'm transmitting a character which has a hexadecimal value of 4.8 or 4.9. Let's make it 4.9. So which means it's 00101001.
All right.
That's what we're going to send. So we're going to send the 1 first. So that means that there's going to be a transition high, and that's going to last exactly for 1 time unit. So that's another 1 time unit. So again, this is whatever you're dealt. This is 1 bit time. So there's 1 bit time here, 1 bit time here.
Okay.
So it's going to be
So
there.
why did we go least significant bit first?
Well, that's just how UART has chosen. They could have chosen the other way, but as long as both the sender and receiver agree on what the order of things is, it's okay.
So they didn't ask us. They just told us to go to least significant bit first. All right.
Exactly.
All right.
And so they decided that the least significant bit. So they transmit the least significant bit. And then now we have a 0. So that's going to be a 0. And that's going to last exactly for 1 bit time again. A second 0, which means that's going to last for 1 bit time again. Then we have a 1, which is going to transition up. And we have a 0 after that. So we're going to come down. And then we have a 0 after that. 2. We have 1 0 after that. As
there you go.
1 after that. 2 zeros after that. So there we go, 2 zeros after that. And now we are finished transmitting our data.
Oh, wait. You know what? That's the bits.
That's the bit. So this is from here
To there
here
is the 8 bits of data.
8 bits of data.
Then what happens?
At that point, we are finished transmission. So we're going to send our stop.
Oh, a stop bit.
And a stop bit is a rise to 1, and that's going to last exactly for another delta t.
So the frame is 10 total bits there, huh?
That the frame is 10 total bits, and at that point we've reached the idle, and this is again back to idle.
Okay. So why do we need to stop it?
So So the stop bit serves two purposes. First, we want to bound our frame between a start and a stop.
Oh, I get it.
And the second thing is, if I have back-to-back frames that I send, then the next frame needs to have its own start bit. And the
I see.
start bit always is a transition from high to a zero.
got it. I
So
got it. Sweet.
that's why we need it. So if there were a back-to-back transmission in this case, then there'd be a transition like that.
So that
and
would be
then I-
another start bit for the next frame.
next frame, and
Oh,
then I'd
sweet.
have
Cool.
data. So that's how exactly how UART's data bits look like as they go on the line.
Sweet.